So the next thing that we're going to talk about is the degree of a polynomial. The degree is defined as the greatest exponent in a polynomial. So I'm just going to circle the exponents of my polynomial. So the greatest degree of this polynomial for sure is degree 3. So all of my exponents here, and recall that a constant has a degree of 0. What we see is the highest exponent is 3. Now let's move on to the next one. The degree of 2x plus 3 is, well, I'm going to write 2x to the power of 1 plus 3x to the power of 0. Now that's kind of an ugly way to write 2x plus 3, but it's equivalent. And what we're able to see is the highest exponent is 1. Because whenever you have x present, there's at least one factor of x. Now the degree of 15 is 0. If you want, you can press pause. Try to convince yourself why the degree of 15 is 0. That's right. 15 can be written as 15x to the power of 0. So this is degree 0. 15 is a constant. It has no factors of the variable x. All right, so let's take a look. We've taken a look at maybe what are polynomials. Let's take a look at what are not polynomials. So I'm going to start off way over here on the most right. And if I take a look at the most right, I'm going to start selecting my exponents. And although 7 can be written to the 7 to the power, or 7 times x to the power of 0, it's these other exponents that make it a non-polynomial. Remember that our exponents have to be whole numbers, and whole numbers are 0 and positive integers. So what we see is negative 2 is a negative integer. If you want, we could also write this in a weird way. We could also write this as 1 over x squared plus 1 over x plus 7. And what we see is that we're dividing by a variable. You can't divide by a variable in a polynomial. Now, also, here, the square root of x plus 3. Well, really, there is no square roots in the definition of polynomials. So this is not a polynomial. We could take the square root of a constant, but not of the variable. Now, I'm going to write this in an interesting way. That is, I'm going to write this as a rational exponent. Now, we may not have seen rational exponents, but when you do, you could say, this is not a polynomial. Well, we see the square root can be written as x to the power of 1/2 plus 3. And now we're able to see, first, is that this is not a polynomial because you can't take the square root of a variable and consider it a polynomial. Secondly, we have an exponent that is not a whole number, not a polynomial. Now, on the most left, you cannot divide by a variable. So this is not a polynomial. That is, the variable x squared needs to be in the numerator or needs to simply be a product of a number and itself. And remember, a polynomial is the product of a variable and a constant, not the quotient. In other words, you can't divide by a variable and consider it a polynomial. So polynomials are written with a specific format in mind. This ensures they're written in a consistent format. So really what we're going to be doing over the next little while is we're going to be training our brain to look at polynomials in one specific way. Polynomials can be written in many, many different ways, but we have to master one. And from that one mastered point, we can sort of go in different directions throughout polynomials and we'll see what we're getting on with.